So now we're ready for the second solution for the lesson 5 problems. So we do see a cannon sitting on the ground launches a ball at an angle of 37 degrees with a speed of 220 meters per second. Because we already see the fact that we have a speed at an angle, we should go ahead and start by breaking that speed into x and y components. Because this is initial speed, we are going to see the fact that we have v y naught and v x naught. All right, y is my up and down, x is my horizontal. All right, so because my y is up and down, it's going to be that 220 meters per second times sine of 37 degrees. And when I go ahead and plug that into my calculator, I get 132.4 meters per second. And then for my Vx naught, I again get the 220 meters per second, but this time it's times the cosine of 37 degrees. And when I put that in my calculator, I get 175.7 meters per second. If you did not get these numbers while you're working along, please make sure that your calculator is in degree mode, not radian mode, because that will mess you up. All right. The next thing that I can note from my problem and how I've gone ahead and sketched this is the fact that I'm given my y naught and my x naught. Right, it is starting on the ground. That means that we are looking at the fact that it's 0 meters above the ground, and we get to pick where that x is, and we're going to go ahead and pick it to be 0 meters just for ease of problem solving. All right, so we want to know the max height of our ball in the air. So we're looking for this distance right here. We want to know what is y. Well, we know something very, very particular about this point on the arc of a projectile. We know that my x velocity is going to remain the same the whole time. My y velocity right here, my vy, is going to actually equal 0 meters per second. So I have my velocity where it's launched right here. I have the velocity where it is at this particular point. I do know that my acceleration in the y direction is equal to that negative 9.8 meters per second squared, and my acceleration in the x direction again is at 0 meters per second squared, just like we saw before. So that does tell us a lot of information about the problem. So we are then able to pick an equation, right? You will need to note that at this particular point we don't have time, so we are not able to pick the equation with time in it. So we're going to be going to this one. All right. Because we know that this term is 0, we're able to go ahead and zero that out. And we know that this term here is 0. So we're able to simplify that particular equation just a little bit and solve for y, because again, we're looking for that max height above the ground. When we solve for y, we get y equals all right. So now we're able to plug and chug all the information that we know into our problem here. All right, and do note that I have negative over negative, so that does help me a little bit in the fact that it's going to end up making my height positive, which means it will agree with my sign conventions that I set up already. So when we go ahead and put that into the calculator, we do see the fact that our maximum height is 894 meters. So it gets pretty tall above the ground. All right, which you should expect since it's going at a pretty pretty quick pace. All right, so that goes ahead and tells us our max height the ball reaches. All right. The next thing we want to know is the maximum range. Well, in order to find the maximum range, we actually need to find the time the ball is in the air. All right, and we are going to use this information. This is the distance from here to here. Well, that's an awful lot like the problem we solved before. The time it takes to get from here to the ground again is going to be the same as the time it takes to get from the ground down here up to that height. So once we find the time to get from either the ground to this height or this height down to the ground, we have the other half, right? So we're going to multiply that number by 2. All right, so we're going to solve this exactly like we did before in the last problem. Remember, we did see the equation that t is equal to the square root of 2y naught over over our acceleration. In this particular case, it was our 9.8. So we're going to go ahead and use this number here. And when we do that, we do get the time for half of our flight. And we find that the time it takes to get from either this point to my highest point or my highest point back down to the ground is 13.5 seconds. All right, so this is only half of the time of flight. All right, so the total time the ball is in the air is going to come from taking this number and multiplying it by 2, right, since projectile motion is symmetrical. So when we multiply that number by 2, we do get a value of 27.02 seconds. Right. So now that we have this number, our horizontal range is going to be treated the same way as we saw the horizontal range treated in the last problem. So we saw that x was equal to x naught plus vx naught t plus 1/2 ax t squared. Remember, our ax is 0, our x naught is 0, so our x was then going to equal to my vx naught times t. This t, remember, is this 27.02 seconds, and my vx naught is this number I calculated here at the beginning of the problem. Right, which then tells me my ball goes really far in the x direction. That is 4,747 meters.